Properties of triangle congruence. So the first property of triangle congruence we have is the reflexive property, which we also briefly mentioned in example 4. The reflexive property says that if we have triangle ABC, then that is going to be congruent to triangle ABC, meaning the same triangle is congruent to the same triangle. I usually think of the reflexive property as you're reflecting yourself into a mirror, so you're seeing the same thing. Now, that's how we would show it if we were dealing with triangles. You can also show it dealing with numbers, and you could say like 5 equals 5. It's the same number, that's the reflexive property. You could also do it with like a side length or an angle, and you could say side DE is congruent to side DE. They both have the same length. Those are all examples of the reflexive property. The next property we're going to be using is the symmetric property, where you could say if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC, which the only thing you did here is you kind of like flipped the order. So another way of looking at that would be, okay, if you tell me that x equals 5, then it's also true that 5 equals x. It's the same statement, except they're written kind of backwards or flip-flopped from each other. If we were using side lengths, you could say that if DE is congruent to AC, then AC is also congruent to DE. Those are all examples of the symmetric property. And then we have the transitive property. So the transitive property says if triangle ABC is congruent to triangle DEF, then we have triangle DEF is congruent to triangle JKL. Then we can say that triangle ABC is congruent to triangle JKL. So this is kind of saying if two things are equal to the same thing, then they're both equal to each other. Another way of looking at that is if A is equal to B and B is equal to C. Then you can kind of get rid of this middleman dude here, and you can just say, okay, well then I know that A has to be equal to C. That's your transitive property. The third angles theorem: if two angles of one triangle are congruent to two angles of another triangle, then the third angle must also be congruent. So if we look at our picture, we can see that angle A is congruent to angle D. They're the same measure. We can also see that angle B is congruent to angle E. Well, what this theorem is saying is that if these two angles are congruent, then we can conclude that angle C is congruent to angle F. Now, if that doesn't make sense, let's maybe look at that in a different light. So let's say that angle A is 30 degrees, which means angle D is 30 degrees. Then let's say maybe up here that angle B is 100 degrees. So angle E must be 100 degrees, because those are the same. Well, we know that all three angles in a triangle add to 180 degrees. So if I take 100 plus 30, right now I'm sitting at 130 degrees. So in order to get up to 180, I know that this one has to be 50. Well, it's also true in DEF because 100 plus 30, we already have 130 degrees over here. So I would also have to add 50 to get to 180. So those last two angles must be congruent. Example 5, using the third angles theorem. So it's telling us to find the measure of angle BDC. So if I go BDC, that's the angle sitting right there, and it's the whole thing. Now, in order to do this, I'm actually going to split my triangles, And I'm going to look at this triangle that's sitting right there. And I'm going to draw him as best I can. This is A, this is C, this is D. I know down here that they told me this is 30 degrees from the picture. I know that this is 45 degrees from the picture. Then I'm going to draw my other one as best that I can. I know that this is C, this is D, this is B. And then if I look really carefully, do you notice the one tick mark sitting at A and the one tick mark sitting at B? So I know that this is 45 degrees. Do you notice the two tick marks sitting down here at D and the two tick marks sitting down here at C? So I know those are congruent. So I know that this is 30 degrees. And what we're trying to find here is we're trying to find the measure of BDC, which is this angle sitting right there. So using the third angles theorem, I know that these guys have to be congruent, or I can just look at what I know already and say, well, I have 45 plus 30, which is already 75 degrees in this triangle. Then I know that all triangle angles have to add to 180. So 180 minus 75 is 105. So I know that this angle has to be 105 degrees.